So, Jeff, thank you for your ongoing support. I give you Jeff Zais, important person from NIWA.
Okay, thanks very much. I really did want to talk to the group about our new supercomputer procurement at NIWA. I'm gonna start my timer. Okay, 10 minutes, I'll be done, yeah. And the idea here is just to present a number of topics, and a lot of them I think a lot of people might be interested in going into depth about benchmarking this or deciding this or that. And I'll be very happy at the break, at the happy hour, or even tomorrow during the unconference day to go into depth, whatever people have interest in. So we'll go there. This is we're installing right now the Generation 4 system, just to get everyone caught up. We think we're the biggest supercomputer user in the country, but it's a small country. And when I talked a few years ago, I made this chart. We've been talking about exascale project and other things, and that was here, and you couldn't even see us on the bar chart because we're so small. You had to go to a log chart to even see where we register. But we do come up with a bunch of the same interesting challenges that you do at other sites. So our first system, we need to run the unified model from the UK Met Office. That's the main code, which scales out to a couple thousand cores. We run 4 times a day our forecast. They had bought a T3E system, T3E 900. We, in 1999, put in the T3E-1200. I call it number 89 in the closet because actually in about the space of this open part of the stage, just plugging into the regular wall in a closet in our Allen building, we got the 89 on the top 500 list. It was a different world then. It was followed about 12 years later. We got a IBM Power 6 based system. Needed 700 kilowatts for power and cooling for everything. So we couldn't find a data center in the country that was really suitable. So we actually built our own in one of our facilities and put that in there. That was followed 2017 and 18. This is when we went really to the big time when we had both a primary and a secondary site. And we did follow the Met Office once again. They had gone to the Cray XC40. We've got an XC50 line. So we needed to replace this. This was coming to the end of life, clearly. So this is the one slide where I'll probably should spend a little bit of time just explaining a bunch of the different topics that we really considered. The very first one, I called this one data first, and that did catch on. That's because our handling of data was the biggest problem that we had. It was all messed up. We didn't have a good path from disk onto our tape archive. We did make the one big mistake that we made with that previous generation. We said, how hard can this be? We'll write the simple tool that does 4 things, which is like move a file to tape, or bring it back, or delete it, or do an LS essentially. And it never really worked. It still is not working. So that was the number one thing we needed to fix. Now, I was pretty much bought into the conventional wisdom that if you have a regular workload, like a 4 times a day weather forecasting, you know how big it is, it makes a lot more sense to have a hosted system rather than use the public cloud. But if you go up a couple levels of management in our organization, we're pretty sure that cloud was the answer. So one thing about our RFP, we had to make it very even-handed, so that we had to really compare a hosted system versus the cloud. And so we went through that, and that was a challenge, but we think we did a pretty good and fair job of that. So we had success there. With operational weather, we did obviously need a primary site. And in case a disaster happens, we have to have a disaster recovery. We considered having our own, or maybe disaster recovery in the cloud, or at another site companion in the network of unified model users. So we considered all of those. As I said, the data and that 20 petabyte archive, we've grown up to save all these files and all this output from our models through the years. We had to find a solution to put that. And we got to actually, I'll give the vendors a lot of credit here. They were very creative about disk or expandable. But it turns out that in the end, we actually do believe in tape, and LTO tape seems to be a pretty standard thing. We think it's got a generation or 2 we're counting on the LTO9 generation that we're installing right now to work. And then I think the technology will be there to do at least the upgrade to LTO10. And what I'll show you is something that will house our 20 petabytes and actually is big enough with that expansion to advancement to LTO10, we'll be able to go to 120 petabytes. And that might be what we do. Traditionally, because we're small, it's easiest just to have one vendor and they've got subcontractors. That's got advantages, disadvantages. We thought this time we will pretty much be the prime vendor, and then we'll have not too many, but about as many fingers as you have on one hand. We're willing to handle that many different vendors. So we did move away to that. I call it a team approach, but actually I was doing the slides. It's more like almost like a family approach, because you really have to work with one another. And so far, because we haven't gotten to the tough acceptance things yet, we're still talking to one another. We're a pretty happy family. Because it's the unified model, we had to run x86. And so we did explore the AMD and Intel options. That was a whole interesting exercise, picking out which processor. For the interconnect, Larry and I need to have another long talk, probably at the happy hour, about InfiniBand versus the slingshot technology. But because we're remote and we were trying to stay as much to pretty standard selections, we ended up with InfiniBand. The one area where I really don't think I had success, I really don't like this HPC bit where you take the big steps, because then you got this big machine and it takes a while to fill it up. You fill the disk up right away, but we could do that technically, but the approval process and the budgeting and everything is just not set up that way. It's really set up for these big steps, and so that's what we had to do. But we did put in the expandability, and we were trying to avoid vendor lock-in. Anyhow, so we had actually, at the time of the meeting last year, we had actually gone through the RFP process, come up with all of our technical recommendations, and I couldn't say anything about it because then we were trying to get approval from the government. They came through, we negotiated contracts. So in August, there was, this is Minister Collins, she was the science minister at the time, having a big ribbon cutting ceremony for vaporware, really. There's a NIWA banner and a CDC banner, but everyone was happy that we were moving forward. And so here's what we ended up with, really. For the archive system, we went with Xenon, really good, capable vendor based over in Australia. They brought in Spectralogic for the archive units. We're going with Versity, who's actually been super helpful, and they have a very good approach for avoiding vendor lock-in quite a bit. And we've added in another layer here, an object store of 2 petabytes that we can simply expand. So that's going really, really well. For the hosting site, Mohammed's here from CDC representing them. We've been very happy with them. So we've got there are 2 sites up in the Auckland area, primary and secondary. For the compute and storage, we stayed with HPE. We went with, I think, what's the XD225. It's liquid cooled nodes packed in a standard size rack. So we get 80 nodes in that one rack. So that's about 100 kilowatts in there. We ended up with AMD processors, the Genoa family, 96 cores. We did go with InfiniBand, and we created islands rather than a big network. But that's fine because we only need to go out to about 8 different nodes, and then we're already running at the scale that we need. And then we did go, the hardest decision, the last decision we immediately made was vast storage for our high performance storage. And I put this with an exclamation point because it's still remarkable. Over one raw petabyte in a one-use space with this new form factor. So we live in a kind of wonderful time. That's what we got. And then what are we going to do with it? I mean, we have to there's so much to do this year, a lot more than we expected, really, because we're putting our operational weather suite into production. Then we're going to have to move to the ensemble approach, because that's the whole reason we bought the machine, to move to that type of thing. Quickly following will be the rest of NIWA research, whether it's the fish studies or the climate studies, everything else. That was all planned. But then not far behind, with the whole research sector rework here in the country of New Zealand, the NESI contractor organization project, it's all shifting into REANs, and a lot of those users will start using our system. So we're going to have to build up the capability to handle them. Later in the year, the government has also decided that NIWA and the Met Service here are both running weather models. They run the WRF code in the cloud, and so they'll probably at some point they'll join as a division of NIWA, and I presume that workload will start running in our system. We should save a whole bunch of money that way. And then, the wider research sector, there were other announcements that came out in the last month or so about how that's going to work. GNS is going to combine with NIWA. We're going to form a new organization, a PRO, Public Research Organization. So that's going to be there. Okay, that is my 10-minute timer. So I'm almost done. The initial deliveries in November. We were happy to get the racks, and they got these nice graphics on them. This week, I've been multitasking. While you guys have been giving your talks, I've been listening, but I've also been watching the flight aware, and this is the flight path. Our racks were built in the Czech Republic. HPE had them, a flight plan, and then they got to Amsterdam, and then I got the bad news call, said, oh, your racks were offloaded. The plane was too heavy. And so they had to come up with a new plan. So they went to London, and then they're on the way. They actually did arrive here in New Zealand yesterday morning. Tomorrow they'll roll into the data center. And so we're calling these systems because the W for NIWA is not water, or not weather, it is water. And so with the water theme, we're calling the new machine Cascade, and the new archive system is going to be called Rapids. So that's a real quick summary of where this is. As I said, I'd be very happy to talk to you later today or tomorrow, or just reach out after the conference too, because there's a lot of exciting things that I don't have time for.
Absolutely.
Same.
To have questions. Any question? Then you deserve to have questions once. Can you just go back to the couple of slides, the number 6? Right. Yes, one.
This one.
Yes. NIWA multi-core sponsor. Rian multi-core sponsor. Cray HPE multi-core sponsor. And here it should say Exaba? They are not picking up, but anyway, I should bring vast storage then as a sponsor. And CDC, of course, I was going to forget that as well. Anyway, join me saying thank you to Jeff. Oh, yes, there is.
Don't worry, it's a quick one this time.
Okay, no, then no. Thank you very much. So see you at the interval. I will give you the, thank you. No,
no, I guess.
There we are. Good.
Okay.
Brilliant.
Right.
Thank you very much,
yes.
and appreciate it.
Yes.
Thanks.
Okay.